So 7.2, guys, the only difference between what you guys did in 7.1 and what you guys did in 7.2 is applied the transformation. So during class, I did talk about the mapping notation, that when you guys have an exponential function in y equals a bracket c to the exponent of b bracket x minus h all plus k, right? The c, guys, is your base function, right? It has the c value has nothing to do with the transformation. So this number here, that's the base function. So your a, b, h, and k, right, are the same things they did, right, in chapter 1 as they do to exponential functions. So everything in the exponent, right, up here is what happens to your x variable. Everything on the outside, your a and k, right, that's what's happening to your y variable, right, when you're dealing with your transformations. So with that being said, the table just kind of summarized, hopefully, things that you guys already knew. So what I mean by table, it just basically went through and described what A, B, H, and K do to the graph, which you guys already know, right? The A value still is a vertical stretch, right, by a factor of A about the x-axis, but then if A is negative, there's a reflection in the x-axis. You know that your B, right, value is your horizontal stretch, and it's always opposite of what it looks like in the equation, right? Your K is your up and down, and your H is left and right. So those variables, right, and what they do don't change. It's the same thing as they always have been doing since we started this course. All right, so with that, I asked you guys to make your way through this lesson on your own. Okay, so please, at any point in time, unmute your mic and ask me questions if you ran into a problem, or put them in the chat. I'm watching both. Okay, so for the very first one, it basically gave you the base function, y equals 3 to the power of x, and it wanted you to graph, right, y equals negative 1/2, 3 to the exponent of 1/5 x minus 5, right, and describing the corresponding transformations. So this one, I'm not going to read through every question, guys, but this one, since it is the first one, okay, everything in the exponent up here, the 1/5 x, that's what happens to the x variable. So that's all my horizontal stuff, right? So that's why I know that there's a horizontal stretch by a factor of 5, right? Because it's opposite, you reciprocate it. There's a vertical stretch by a factor of 1/2. In class, when we did chapter 1, some of you still were putting that negative there. Please, at this point in time, we should never be doing that anymore, right? The negatives on the A and the B have nothing to do with the stretch, right? The negative shows you that there's a reflection. So vertical stretch by a factor of 1/2, reflection in the x-axis, horizontal stretch by a factor of 5, and then 5 units down. Yeah, Raymond, go ahead. Because we could open up our unit 1 notes, right? So remember when we did all that. So what I would suggest you do, because I'm not going to go through that whole explanation again, if you go to lesson number 3, I think, in chapter 1, when we graphed all them, right, when we did the horizontal stretches, we seen that when there was like a, say, a 1/5 here, it didn't actually stretch it by a fifth, it stretched it by 5, right? So everything to do with our horizontal stretching, right, we learned the why of that all in chapter 1, right? So when you graph it, even here, you should see, well, it's harder with this one, but when we did our quadratics, and if we had something that was really skinny and we had a 5 1/5 x in the equation, and we horizontally stretched it by a factor of 1/5 in the equation, but what actually happened is it got 5 times as wide. So yeah, I'm not sure what else to say. Yeah, go back and look and watch the video from, I think it's lesson number 3 in chapter 1. Yeah, that's all good. It's been a little bit of time, but all our stretching, right, all our horizontal stuff, guys, remember, is opposite of what it looks like, right? Which is important that you guys remember also for our midterm and stuff coming up. All right. So then you graphed it, and you can use your calculator. It's not a big deal. The biggest thing I want you guys to realize is when you're looking at an exponential function, because it is a little bit different, because in all the other functions we've done, right, usually an x was our base, right? Where here, it's 3 to the exponent of x is our base, right? So it's a little bit, you just have to realize that this number here has nothing to do with the transformations that are being applied, right? We are applying the transformations to this. So therefore, anything that's outside of this base function, you have to understand what the transformations are. All right. So then you graphed it. Hopefully you guys realized from the first lesson that we did and the second lesson that you did, your exponential functions are going to have a horizontal asymptote, right? So this one was a little bit harder to see just because of the scale that I used, okay? But you know that your base function has a horizontal asymptote, right? All of your base functions, like y equals 3 to the exponent of x, or y equals 1/2 to the exponent of x, as long as there's no transformations that applied to the original function, it's going to have a horizontal asymptote on the x-axis, okay? So if I give you a function, you should be able to, just by looking at it, know where the horizontal asymptote is, because your asymptote is going to move with your vertical translation. Your vertical stretch will not touch an asymptote, right? Your horizontal asymptote, but your vertical translation will. That's what's going to move that asymptote up and down, okay? So just to make it clear, if I gave you something like y equals 4 times 2 to the exponent of x plus 7, okay? This is your base function. This function here has a horizontal asymptote, right, where y equals 0. That's your x-axis. So if I do this to you, okay, all that's going to do is move that horizontal asymptote, because remember, you apply your stretches first. So this vertical stretch by a factor of 4 does not move the asymptote, but plus 7 moves it up 7, right? So this would have a horizontal asymptote at y equals 7. And then your graph would go around that, because remember, your horizontal asymptote is where the graph approaches, okay? And in 30-1, we're not going to touch the horizontal asymptote and go and approach it on the other side. We're going to approach it on the same side that the graph came from. All right. So then here it just says, describe the effects of the domain and range, equation of the horizontal asymptotes and intercepts. So hopefully I told you guys when you were working on this last week that I would have the key here to double check that you were looking at it correctly. So the domain, right, if I have a base function and I apply stretches and reflections and translations to it, it's not going to affect the domain, right? Because it's still going to go forever left. It's still going to go forever right, okay? So that's why I said the domain of both functions is still negative infinity to positive infinity, right? Or x is an element of all reals. But what is affected, as soon as that asymptote, that horizontal asymptote moves, that is going to affect the range, right? Simple as that. So the graph is not going to touch the asymptote. So that's why it's always going to be a greater than or less than symbol to the asymptote. So this one, we knew that the horizontal asymptote was at -5, but since there was a reflection in the x-axis, it got flipped underneath, right? So that's why it's really hard. I should have given a little bit more graph paper, right? Just so you guys could see the curve a little bit more. But since there was a reflection in the x-axis, it's not actually above the asymptote, it's below the asymptote. So that's why the range changed. That was like almost a tongue twister, right? So range went from greater than 0 to less than -5, right? And you can see that from the graph that you guys graphed. And then obviously the horizontal asymptotes changed. So I'm not going to worry about that. In this situation, they both don't have x-intercepts, right? Because the top one approached the x-axis but never touched it. And the bottom one has an asymptote at -5, right? And it's below that, so it's never going to go up above and have an x-intercept. So both of them don't have x-intercepts. And just realize, guys, exponential functions can have an x-intercept depending on where the asymptote is, right? But neither of these two graphs do. Okay. And then y-intercept, right? So the y-intercept of the original, right, was 1, right? So the y-intercept of the base function is 1, and the y-intercept of the transform function is -5.5. You could have calculated those off the calculator, but to me, remember, to get your y-intercept, you just let x equal 0. So you could have just put a 0 in here, right? 1/5 to the times 0 is 0. 3 to the exponent of 0 is 1. 1 times -½ is -½ -½ minus 5 is -5.5. So you could, right now, do your y-intercept algebraically. You cannot do your x-intercept. So if there was an x-intercept, guys, right now, you would have to do it on your calculator, just because you don't have the algebra skills yet until we do the next chapter, to solve for a variable that's in the exponent. All right, questions so far, guys? I know I'm talking lots. Should go pretty smooth if you have this done. Okay, so I'm just going to make sure that you guys checked all these. And again, interrupt me at any point, guys, if you have any questions. So example 2, so these are all diploma style questions, guys. So this one just says the y-intercept of the graph, blah, 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 right, has a bunch of variables. So as soon as it says y-intercept, guys, you should be thinking let x equal 0. So if you did that, you would have got D as an answer, right? Because it's not an actual numerical value, right? We're coming up with an expression for what the y-intercept would represent. Okay, so the your turn. We've done a million questions like this where I give you a point on the original function, right? And you have to transform it, right? Move it according to the new transformations. So see how y equals 4x. This one still has a base function of 4. You just have to do your mapping notation, right? So if I do my mapping notation, everything in the exponent is what's applied to the x. And remember, everything's opposite. So there's a horizontal stretch by a factor of half, reflection in the y-axis, and then moved 5 to the left, right? And then everything on the outside. So there's nothing out here, right? Not out there, but there's nothing in front of the 4, because that's where the stretching, vertical stretch, and the reflection in the x-axis would occur, but there's nothing there. Only thing vertically that's happening is a vertical translation of 3 down. So that's my mapping notation. So then if you use mapping notation, this should have went smoothly, right? As long as you did it correctly. And something I've stressed a million times before, guys, before you do your stuff that applies to the x, even for that matter, your vertical stretch stuff, please make sure, well, your vertical stretch stuff is just always in front, but your horizontal stuff, please make sure your B value is factored out. That caught a lot of you when we did this in chapter 1. Even though I stress it, if you don't have your B value factored out, then your horizontal translation is wrong, right? So what I mean by that, if I gave you this question written like this, right, and you go into your mapping notation looking at this, then you'd probably go, okay, that's very wrong, right? It does not have a horizontal translation of 10 units to the right. So B value, factor out, factor out. Right, so this one was factored out, so you didn't have to worry about it. All right, so any questions with the your turn that you guys did? We're not doing anything unless somebody responds. Yes, no, we're good.
Yeah, we're good.
Thank you. Thanks, guys. All right. And then example 3 is just another diploma style question. You have to know the characteristics of an exponential graph, right? So here it just said Laura sketched the graph of f of x equals 2 to the exponent of x minus 1 plus 3 is shown. And then Laura also determined the following characteristics of the graph. So domain, range, y-intercept, x-intercept, equation of the asymptotes. Sorry, equation of the asymptote, not plural. So it says when y equals f of x is vertically stretched about the x-axis by a factor of a, where a is greater than 1, the two characteristics above that will remain the same are, right? So if we vertically stretch this graph, right, if we vertically stretch it, right, that is not going to affect the domain, right? It's still going to go forever left. It's still going to go forever right, right? That has no effect on covering all the x-axis numbers, right? But it definitely will affect the range. Because again, guys, you don't know what the number is, but you know that right now, this little guy here is at 3. So if I vertically stretch that, that whole thing is going to go up. So it's no longer going to be going through 3, or sorry, that's actually 4, right? Because if I put a 0 there, or not 3, so 0 there is negative 1 half, so 3.5. So that's going to go up, right? And it's going to be looking like this if we vertically stretched it. So it's definitely going to affect the range, right? X-intercept, it's not going to affect that because the original didn't have any x-intercepts, right? So then this one's just going to be even further up, so it wouldn't have any x-intercepts. Y-intercept would definitely be affected. Whatever this y-intercept is, I think we said it was 3.5, right, is now going to be 7. If, again, I'm just randomly picking numbers for what the vertical stretch could be, but this is what you kind of have to think about is problem solve through each kind of scenario. And the equation of the asymptote is definitely going to also change, right? Because right now the asymptote, right, is at 3, right? The y-intercept's at 3.5. So your asymptote is now going to be at 6, right? Because it's now going to move up vertically if the vertical asymptote was, or vertical stretch was 2. So randomly, if you're not sure, guys, randomly pick a value and apply that transformation to it so you can physically see. Okay? So if you got 1 and 3, you're good. And then the last one, guys, that I asked you to do, you didn't have to do any of the homework, right? So what I'm basically going to do is the first part of class here, I'm going to give you 15-ish minutes to do a few more questions from the textbook to apply the transformations, right? Make sure that you're good with that. And then this last example is just another graph. So what I would hope you guys can do is put away, the other thing I want to say, a couple things I want to say here, is be able to answer all these questions without touching your calculator, okay? Except this one, right? So this one right now, guys, you have to use your calculator for. And the other thing I needed you guys to change, which is probably if you did the question, is y-intercept, please, to the nearest hundredth, because it rounds to 1, and that's where the asymptote is. So that shouldn't say tenth, it should say hundredth, because we know that there is no point on the asymptote, so change that. So this one here, right, to do your y-intercept without using your graph, right, you would have just did, whoopsie, again, you would have just let x equal 0, and then still used your calculator and type all that in. So if you went negative 2 bracket 3 to the exponent of 0 minus 4 close bracket plus 1, you would have got 0.9 blah, 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 blah. It was really, really close to 1. But again, x-intercept, this 3.4 right now, guys, because you don't understand logs yet. So chapter 8, to do that one algebraically, you would have to let y equal 0, which you guys know how to do that. It's just, I promise you, after we do chapter 8, you'll be able to get this number without using your calculator. So right now, all you would be doing is putting in your equation into y1, 0 into y2, find the point of intersection, that is to the nearest 10th. And you're done. Okay, so quick summary of what you should be good at after you do these questions in a second is if, again, I gave you don't write this down, I just want to have one last quick conversation. So if I gave you something like that, I'd expect you to know what the domain and range is. I'd expect you to know where the asymptote is, right? I'd expect you to be able to get the y-intercept. And then x-intercept, you'd have to use your calculator. And then obviously describe all the transformations, right? So here, you know that the horizontal asymptote would be at 7, right? I'd also expect you guys to know if this was an increasing or decreasing graph. That's the other thing. And hopefully you guys remember that this C value here, the base number, always tells you if it's increasing or decreasing. That's what we learned from 7.1, right? If it's a number between 0 and 1, it's decreasing. If it's a number greater than 1, it's increasing, okay? And then also we know that there's a vertical stretch by a factor of 2, a reflection in the x-axis, a horizontal stretch by a factor of 3, a horizontal translation of 4 units to the left, and a vertical translation of 7 units up. Okay, so all the transformation knowledge from chapter 1 is pertinent that it's still somewhere in your brain to bring forward. Okay, and then how you would figure out your range. We know that the graph is either above 7 or below 7, right? So either y is going to be greater than 7 or less than 7. So then you just look to see if there's been a reflection in the x-axis. Because a horizontal reflection, right, a reflection in the y-axis isn't going to affect anything, but a reflection in the x-axis is going to affect the range, right? So see how there is a reflection in the x-axis. So since that's there, my range would be y is less than 7, right? Because before it was above, but it got reflected. And you're done. So hopefully that was okay. If you had the lesson done, that should have went hopefully smooth because you guys aren't asking questions. So that tells me you either did it and it was easy or you just didn't do it. Those are the only kind of 2 cases that could happen. So what I'm going to do is give you guys, it's 1 o'clock right now, 15 minutes, and I'm here the whole time regardless, to do some questions from 7.2. Even if you think it's the easiest stuff in the world, guys, please do not be skipping your homework, right? That is not a good thing in 30-1, which is a lot of you are figuring out the hard way. Please, 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 please be doing your homework. So at 1:15, that's when I'm going to come back formally and start solving some exponential equations with you guys. So any questions before we do that?